Good morning, students. In this session, we are going to discuss about data rate limits. Last class, we had discussed about the transmission impairment. Do you know what is transmission impairment? The signals travel through the transmission medium which are not perfect. So, the imperfection causes the signal impairment. So, what is the impairment means? The transmission impairment, this means that the signal at the beginning of the medium is not the same as the signal at the end of the medium. Because when you transmit the signal from the sender side, the noise will be added. So in the receiver side, the data is not perfect. So the input signal different with the output signal, that is the transmission impairment. In this class, we are going to discuss about data rate limits. So what is data rate limits? When you send and receive the data through the data communication, that is very important one is how fast we can send the data in bits per second over the channel. The data rate depends on three factors. First one, the bandwidth available. Number two, the level of the signals we use. Number three, the quality of this channel. The third one, the quality of the channel depends on the noise. Because when you send data through the channel, some noise will be added. So the data rate depends on these three factors. There are two theoretical formulas were developed to calculate the data rate. First one, Nyquist for a noiseless channel. Number two, Shannon for a noisy channel. But when you send the data over the network, always some noise will be added with the signal. So these are the two theoretical formulas to calculate the data rate. So first one, we move to first one, noiseless channel. This is a Nyquist bit rate. So for the noiseless channel, so the bit rate formula is 2 into bandwidth into log L to the base 2. Using this formula, we can calculate the bit rate in the Nyquist. There's a Nyquist bit rate in the noiseless channel. So the bitrate formula is bitrate equal to 2 into bandwidth into log L, capital L, to the base 2, where bandwidth is the bandwidth of the channel. L is the number of signal levels. Suppose 2 signal levels, L equal to 2. 3 means L equal to 3. Okay. So where L is the number of signal levels used to represent data. Then bit rate is the bit rate in bits per second. Then the bandwidth is the fixed quantity. So it cannot be changed. Hence the data rate is directly proportional to the number of signal levels. But one thing you might, increasing the level of a signal may reduce the reliability of the system. Then one example for a noiseless channel, you consider a noiseless channel with a bandwidth of 3000 Hz transmitting signal with two signal levels. What can be the maximum bit rate? So now we have to calculate the bit rate. So the bit rate formula is bit rate equal to 2 into bandwidth into log L to the base 2. In our example, the bandwidth is 3000, then L equal to number of signal levels. So in the given problem, the number of given signal levels is 2. Okay. So now we have to apply the bandwidth and the value L equal to 2. So the bit rate equal to 2 into bandwidth 3000 into log L. What is the value of L? In this example, we use 2 signal levels. So L equal to 2. So we have to apply 2 for L. So log L to the base 2. That's equal to log A to the base A is always 1. So log 2 to the base 2, that is equal to 1. So 2 into 3000 into 1, that is equal to 6000 bits per second. Okay, this is the example in the noiseless channel to calculate the maximum bit rate. Now you write the formula, then you apply each and everything. So what is the bandwidth and what is the L, the value of L? The value of L depends, that is a number of signal levels. So in this example, signal levels, that is equal to 2. So when you apply these values, we can get the bit rate that is equal to 6000 bits per second. Then next one, noisy channel. There's a Shannon capacity. Okay, how to calculate the capacity? When you send and receive the message through the network, the channel is always noisy. But in reality, we cannot have the noiseless channel. There's a reason. So the channel is always noisy. Shannon capacity is used to determine the theoretical highest data rate for a noisy channel. So the formula is the capacity that is equal to bandwidth into log 1 plus SNR. SNR means signal to noise ratio. So last class, the transmission impairment, we already calculate the signal to noise ratio, SNR. So SNR is a noise to signal ratio. Bandwidth is the bandwidth of the channel. Then capacity is the capacity of the channel in bits per second. Normally, the capacity can be denoted by the letter capital C. So in the noisy channel, there's a Shannon capacity. We can calculate the bit rate. So the formula is capacity equal to bandwidth into log 1 plus SNR to the base 2. Bandwidth is a fixed quantity, so it cannot be changed. Hence, the channel capacity is directly proportional to the power of the signal. Okay, then you have to find out the SNR value. Then only we can apply in the capacity formula. So SNR equal to power of signal divided by power of noise. The signal to noise ratio, that is usually expressed in decibel, that is dB. Okay, so given is expressed in decibel given by the formula, that is equal to 10 into log S by N. That is S by N, that's a signal to noise ratio to the base 10. So for example, signal to noise ratio is 1000 is commonly expressed as 10 into log S by n, that is the value is 1000. So log 1000 to the base 10, that is equal to 30 dB. dB means decibel, because signal to noise ratio is expressed in decibel. Then one example, in the noisy channel, a telephone line normally has a bandwidth of 3000 Hz. Assigned for data communication, the SNR is usually 3162. What will be the capacity for this channel? Normally, the telephone line's bandwidth may be 300 to 3300 Hz. But in our example, the telephone line bandwidth is 3000 Hz. So, we can apply the value for the bandwidth 3000 Hz. Then SNR value in the given example 3162. Now we have to find out the capacity. Capacity capital C equal to bandwidth into log 1 plus SNR to the base 2. Now we have to apply bandwidth and SNR value. So the capacity C equal to bandwidth 3000 into log 1 plus SNR to the base 2, that is equal to 3000 into log 1 plus SNR value 3162 to the base 2, that is equal to 3000 into 11.62, that is equal to 34,860 bits per second. This is the example for the noisy channel to find out the capacity. Thank you, students.